As we've seen in a previous lesson, we can simplify polynomials by collecting like terms and then adding or subtracting them. Now remember, like terms are terms that have the same variable, same letter in other words, or group of letters, it can be more than one letter, with the exact same exponents on each letter, okay? What doesn't have to be the same is the coefficient. The numbers in front, any numbers other than the exponents, let's say, don't have to be the same in order to be like terms. So for this first example here, we've got, remember, if we got them in brackets and there's plus sign between them like this, then we can take the brackets off. We have the same thing, so it would be 2a squared plus 5ab minus 2b squared. Then we just take the brackets off, plus 3ab minus 5a squared minus 7b squared. Okay, so the like terms are going to be the ones with a squared in it, just a squared. The ones that have a times b, those ones, and the ones that have b squared. Notice I'm only highlighting the variables and the exponents because, again, the numbers have got nothing to do with whether or not they're like terms. So if I put the like terms together, I've got 2a squared minus 5a squared. I've got 5ab plus 3ab. And I've got minus 2b squared minus 7b squared. So those, I put all the like terms together. I can think of those like they're three different questions, one for each color. So for the first one, the yellow question, if I've got 2 of something and I take away 5 of it, then 2 minus 5 is negative 3. Let's just think about subtracting 5 from 2. I get negative 3, and it just stays as an a squared. So that becomes this term. And then if I have the ab's, the green one, I've got 5 ab's plus 3 ab's gives me 8 ab's. So that would be what that combines down to. And I've got negative 2b squared minus 7b squared. So minus 2 minus another 7 becomes negative 9. And then it's just b squared. You notice how it doesn't change. It's still just the b squared or the ab or the a squared. Those don't change. I just have how many of them. Now if we compare the three different colors, they're all different types of terms. We got an a squared term, we got an ab term, and we got a b squared term. I can't go any farther, okay? Now remember, this one's a little different. The only thing different really is that minus sign in the middle. It means when I take the brackets off, I want to change all the signs. Well, actually, I guess how I showed it last time was to rewrite it as a plus sign and then change all the signs in the middle. Minus 3x plus 9. So I changed all those signs in the second bracket after I changed this minus to a plus, right? Then I can take the brackets off just like I did in example 1. First brackets stay exactly the same. Second brackets, I take those away and I just take the signs I've got. And then different types of terms. There's an x squared term and an x squared term. There's an x term and an x term. There's a couple constant terms. They've got nothing with them, so that makes them the same. So if I put my x squared terms together and my x terms together and my constant terms together, then it looks like this. And again, I just add the same types of terms together. Negative 6 plus 4 is negative 2, and it just stays as an x squared. 7 minus 3 is 4, and it just stays as an x. Minus 3 plus 9 is 6. And I won't bother highlighting the colors. You should know where they came from, but you'll also notice that they're not like terms. I've got an x squared term, I've got an x term, and I've got a constant term. I can't go any farther. I have to know when to stop. So we got a few different types of examples to look at in this lesson. The first one is something to do with, Sorry, example 1, example 2. Sorry, I was wondering why is example 3. I'm good now. Here's a student's solution for expanding negative 2 times 3p squared plus 5p minus 6. Identify the errors in the solution, write the correct solution. Okay, so remember, this is also something we've looked at before, something called the distributive law. What I'm really doing is distributing this negative 2 across each of the terms inside the brackets. So I'm multiplying negative 2 times 3p squared, which is exactly what I got for the first one. And I've got negative 2 times 5p, which is also good. And negative 2 times, should be negative 6 for the last one. So really what the problem with this one is the signs. If I want to multiply a number times everything inside the brackets, this should become a plus sign. I should always just make this a plus and then stick with what I've got. So plus negative 2 times 5p plus negative 2. And I should make this think of the negative sign as being with the 6. So keep the signs with the numbers and just put plus signs in between them always, and that'll make things easier. So we know this is wrong. Whoops, that was supposed to be just crossing it out. So what we'll have instead is negative 2 times 3 is negative 6, p squared. Negative 2 plus minus 2, so it's minus 2 times 5 is 10, p. Plus minus, so again, I got negative 2 times negative 6 gives me positive 12. Okay, so there are a couple mistakes in that example. The 2 mistakes at the end, 2 wrongs did make a right. In other words, they did get a plus 12, as you can see from what the line I crossed out. It was a plus 12, which is what it was supposed to be, but they came about from the sort of the wrong way. Whereas the sign in the middle, the 10p, definitely should be a negative 10p, so that needed to be corrected. Now we're going to combine a couple things together. This is where it starts to get interesting. We're going to combine the distributive law with the adding and subtracting. As always, order of operations must be maintained. So distributive law is multiplying, right? This distributive property is a multiply, and obviously adding and subtracting is adding and subtracting, which means that I need to do the distributive property first. Then I can collect my like terms. So I'm going to multiply 3 times 2x, and I'm going to multiply 3 times 5. Now, we don't have to write everything out all the time. There's examples up above where I was writing out, changing the signs, and this example here where we had all the multiplications written out. Once we get a little bit better at doing stuff in our heads and understanding it, then it's okay. So if I look at this first part, 3 times 2x, I would do the 3 times 2. That would give me a 6, and then the x stays the same. Then I'd move on to 3 times 5, which would be 15. Then I'd move on to the next part, and I'm going to do distributive law. I'm going to think of this like it's my number, the minus sign with it, and do negative 6 times negative 2. And if I do that, negative 6 times, sorry, not negative 6 times negative 2, negative 6 times each of them, the 3x and the negative 2. So if I do the negative 6 times 3x first, what I'll get is negative 6 times 3 is negative 18, and again, I've got my x. And then if I do the negative 6 times the negative 2, then negative times negative is positive, 6 times 2 is 12, and that's what I get from my expanding line. Now I get to the part where I start looking for like terms, right? I've got 2x terms, I've got 2 constant terms, I'm going to put those together. Notice how I'm going to move the minus sign that's in front of the 18 with it. That's a big deal. If you forget that, then things are going to go wrong quickly. So it's going to be 6x minus 18x. I'm moving everything. I'm thinking of that minus sign in front of the 18 as part of that number. Signs will always go with the number that comes right after them. So then I got a plus 15 and a plus 12, so they're both going to have those signs moved with them. So then if I do 6 minus 18, we've seen before that we could just do 18 minus 6 is 12 and take the sign of the bigger one. It's going to be minus 12x. That's what that simplifies down to. And then 15 plus 17 is 27. And again, I've got two terms that are not like terms, so I would leave it like that. Okay. This next example is the exact same idea, except now we're got a couple trinomials here. So I'm going to multiply this 3 times each of these 3 terms. And I'm going to multiply again. I'm going to think of this negative 6 or this minus sign as part of the 6. So I'm going to think of it like it's a minus 6 times each of these 3 terms. And so I've got 6 multiplications to do. I'm going to start with this one. And 3 times 2 is 6, and it's an x squared. Then I'm going to do 3 times negative 5. That minus sign is going to be considered part of the 5. And so I'm going to have negative 15x. Then I'll do 3 times 7, which is going to be positive 21. Then I'll move on to the next part, and I'll do negative 6 times x squared. I'll get negative 6x squared. I'll do negative 6 times positive 2. And I'll get negative 12x. And I'll do negative 6 times negative 1. Those two negatives are going to combine together to make it positive, and 6 times 1 is just 6, so it becomes plus 6. So there's the distributive law part. Now for like terms, I've got a 6x squared and a minus 6x squared. I've got a negative 15x and a minus 12x. I've got a couple constant terms, so I'm going to rewrite them beside each other. Again, notice how I'm moving the minus sign in front of the second 6x squared along with it. So I'm moving this minus sign over to here. Then I go to the minus 15x and the minus 12x. Those minus signs both move as well. Plus 21, plus 6. So 6x squared minus 6x squared. Anytime you subtract something from itself, it goes away. That gives me 0x squared, which is nothing, right? So really those just cancel out. I've got no x squareds left, so I don't even need to write it down. So I won't even bother writing down any x squareds. They've gone away. I'll move on to the green ones. And, oh, I forgot to write the x beside that 12 there. Sorry about that. There it is. Minus 15x, take away another 12x. Remember, if we've got two things with the same sign, we just add them together. 15 plus 12 is 27. And then I take that minus sign since they're both minus, and it's minus 27x. 21 plus 6 is 27 again. So we've got two terms left. Since the x squared terms cancel out, one's an x term, one's a constant term. They're not like terms, so I can't go any farther with that. That's the end for that one. Here's one kind of application we can do for polynomials. We want to represent we want to write a simplified polynomial to represent the area of the figure below. So I'm going to simplify it in the end. In other words, I'm going to have to do some expanding. And I'm going to do area, which you may remember is the formula for a rectangle anyway, is length times width. Now we got this weird shape going on here. What I probably want to do is break this down into two separate shapes. So if I draw a line down here, then I could have one shape that just goes to here, and another shape that just takes this part. So I can have these two rectangles, and I can add everything together for that. So if I think of the shorter side as the width, this would be a width, and this would be a width, right? And the longer sides as lengths, so this could be a length and this could be a length. But I've got these two different rectangles. I'm going to add them together. So the area for the yellow rectangle is length times width, or we could, it doesn't matter what order it's in. It could be width times length. And I'm going to do width times length just so I can put the 2x out front. I want to put the monomial out front. It's just going to be a little easier to understand. So 2x times x plus 3 is the area of the yellow rectangle. That's width times length. And to that, I need to add the area of the green rectangle, right? The width of that one was 3x, not 3w, 3x times 6x plus 2. That's the width times the length for the green rectangle. And now what we've got is something that just looks like the questions that we've done farther up. I'm going to multiply 2x times 3x, and I'm going to multiply 2x times 3, and I'm going to multiply 3x times 6x, and I'm going to multiply 3x times 2. This one's got an added thing that we have to watch out for there, because now we've got x's out front here. In the examples we've done up till now, we didn't have any x's out front that we had to multiply by. We just had 2 or 6 or whatever, just numbers. So remember what we do. We're going to, for this first one, we're just going to multiply these two together. And so when I do 2x times 3x, 2 times 3 is 6. But I'm also going to do x times x. So I got to multiply this part times this part. X times x is x squared. Remember, we talked about this in the past. We can think of it as x to the 1 times x to the 1, and then we would add the exponents together, which so it would be x to the 1 plus 1. So we get x squared for that first multiplication. Then for the next part, it'd be 2x times 3. There's no x after that 3, so it's just the 2 times the 3, which gives me 6. And I take that x that's already out front and I write it beside that 6. So you notice that these are two different types of terms. One's an x squared, whereas the other one doesn't have that exponent 2 on it. Those are not like terms, and they're not supposed to be from this question. Going on to the next part, I'm going to do 3x times 6x. So the same thing's going to happen again. And then in that, I'm going to do the 3 times the 6, which is 18, and I'm going to do the x times the x, which is x squared. I'm going to highlight these guys in the same colors just to keep things a little clearer for now. Finally, I'm going to do 3x times 2. And 3x, again, there's no x in that last 2, so just 3 times 2 is 6. And then I just write the x beside it. So again, those are those parts. But now I have to collect like terms again. So I've got x squared terms. So I got 6x squared and 18x squared. And I've also got just x terms. So I've got 6x and 6x. So I'm putting the like terms together. And as far as that goes, these are like terms. This is another set of like terms. So 6x squared plus 18x squared. I just do 6 plus 18 is 24, and it's still x squared. It doesn't change to x to the 4 or x to anything else. It doesn't change the exponent. It's just x squared. Likewise, if I have 6x and I add another 6x, I end up with 12x. It doesn't change it to anything different. This would be my final answer. I've got two different types of terms. One's an x squared term, the other one's just an x term. And we can't go any farther, so we're done. So this lesson was all about combining a couple things, combining the distributive law and the adding and subtracting of like terms in polynomials. Definitely important to be able to put them together. So good luck.